Good afternoon. My name is Juan Yactayo. I'm the lead automation engineer for Aera Energy. So a little bit about Aera. Aera founded in 1997. It is a California onshore exploration and production asset. It's a joint venture between Shell and ExxonMobil and ARCO. Jointly owned at this moment by Shell and ExxonMobil. And we operate safely and responsible in California. Let me see, what's the next slide? We are one of the third largest producers in California. We make over 25% of the state total production. I think I have let me see if I can. Have around 1,100 employees and thousands of contractors and $2.1 billion of revenue. And we provide support to multiple agencies locally in California. We produce around 113,000 barrels of oil, 30 million cubic feet of natural gas, and 430,000 barrels of steam. We have 495 million barrels of oil equivalent as part of our reserve. And we have around 10,000 producing wells, 3,300 injecting wells, and over 6,000 wells drilled in 2019, so it's a significant large operation in California. Where we operate in the central area in California. Our base is in Bakersfield, north of LA, and we have fields in Coalinga, Sonora, Simbrick, Midway, Sunset, and Ventura. Ventura is a little bit south from Santa Barbara. It's probably the closest to the coast. And we operate responsible on all those areas. All right, so that's a little bit of Aera. So I'm going to be talking about the journey on selecting a platform for a modernization project that we have currently in a newly formed IT/OT organization. I'm going to talk a little bit about the strategic objectives and how we integrate cybersecurity as part of that. That was something that it was new to me. My background is mostly process control and process safety, so I'm slowly transitioning, incorporating cybersecurity into the decision-making process. We develop a PLC hardware selection process, and I'm going to talk about how we incorporate some of those requirements. We also explore codices. We start looking at open source as one of the alternatives for code development, and it's part of our decision-making process. And as part of that, we selected Bedrock as our primary supplier, and we had to develop a little bit of a local support. Every time you bring a new platform, you have to figure out how to support it locally. So I'm going to talk a little bit about that. And I separated the things that we did into software improvements, hardware improvements, and a little bit of summary of what we learned on this journey and what we learned out of the pilots that we currently have. So, all right. So, with that, the strategic objective was really we have it's a pretty common issue with aging PLCs, right? They're all at the end of life, and we have to develop a holistic approach on how to upgrade all those PLCs. And in the process of that, we also decide to incorporate processes and standards to reduce risk. And the reduction of risk was not only on process safety. We want to reduce risk on cyber, process safety, and operational improvement as needed as part of that process. And we also wanted to select a platform that could easily be integrated to our HMI platform system. In this case, it's Ignition. And we also wanted to select a platform for all new projects. So we have this, looks like a daunting task of selecting a platform that was able to be used for new projects, but also at the same time replace existing end-of-life PLCs that we found vulnerabilities with. One of the things that we also found is that older systems didn't have a lot of troubleshooting techniques. I would say troubleshooting capabilities. The data was not exposed to the technicians in a way that they could troubleshoot and determine what was failing, and it took a lot of time from the field technicians to identify what was at fault, and we added significant amount of diagnostics to help with some of the troubleshooting. And so we wanted to have a mix of new and existing technologies, and one of the key aspects of the strategic objectives was to reduce complexity. There's multiple vendors, and they all have different degrees of meeting our cybersecurity standards, and we something simpler, easy to maintain, was really in the priorities. We wanted to improve safety, obviously, because it's equipment at the end of life that could fail, it could put the plant at risk. Security and reliability. So it was really not one wins. It's just trying to find the right balance between those three things. So what we needed when we started looking at the platforms that we looked at, we were looking at optimized runtime. We had a number of things that, I mean, when you did the code 30 years ago, I guess optimization processes wasn't really part of the scope of any project, right? It was just, let's get it going. It was probably going from manual or even pneumatics probably, or relays to PLC. That was really the improvement, right? So this go around, we wanted to optimize how we run those facilities. We want to make sure that we get something back in terms of from the operational side. We wanted a robust life cycle of the PLC equipment. So we found that cybersecurity being one of the items that keep changing every number of years, every 10, 15 years, it looks like there's a big shift on requirements, which makes the team almost to the point that it's like the life cycle was almost driven by cybersecurity rather than the aging of the technology. So we found that shift. Or it would take a significant amount of energy to secure those systems. So we want to make sure that whatever we put in would last 30, 50 years. And we want to get every dollar out of that system. And this is probably, and I have to say, with someone in the audience that put a lot of work into that, it's Alan Ray right in the middle of it. That's also, if you have questions, he will probably be able to help. I told him I would do that. So that was his thing. He really wanted what best cybersecurity available in the industry. So he got to the point that doing what it was like required today wasn't sufficient, because the problem is some of those projects takes 4 or 5 years just to get it implemented. So if you start with what is needed today, and then you deploy those projects, then by the time you deploy those projects, it's already obsolete. So you're already patching things because what you thought you needed is not there anymore. So we have to push the envelope and say, we're just gonna get the best of the best cybersecurity. I'm probably gonna try to work around other issues. If we have other issues, we'll work around other issues, because cybersecurity, it was gonna be the one thing that it most likely would change in the near future. The other thing that became very interesting is a discussion about retaining engineering costs on the codices side. It was very obvious that every time there's a major upgrade, it almost felt that you have to rewrite the entire facility, and that was very costly. So we wanted to retain some of that code, and that's where open source was attracted to us, because it's pretty much hardware agnostic. It's just no matter what you put in the future, you will most likely be able to retain the code if we decide to go to another platform. Not planning on doing it. So, but it was a good opportunity to incorporate industry best practices around 61131-3. Really is using the right programming language for the right problem. So if sometimes there's a trend, everything is ladder, there's another trend, everything is structured text, hopefully somewhere in the middle, areas that we can, and around that industry best practices, it was really, our mantra was easy to troubleshoot. We want to make sure that whatever we put in was really friendly to our customers, and that was not easy. So we developed some standards. So that was the biggest challenge, is I start going into the actual hardware selection, and we're start looking at what is needed. Okay, now we got the platform. Now what do we need? So unfortunately, especially when we start looking at Bedrock, didn't have enough templates in the industry, so we brought large integrators to help us with the developing of those templates. And after roughly 8 months, we have a base library. And that's actually round two. I think there was a team that spent close to a year working on the templates, deploy, learn from it, got another team to continue working on it. I would say it was probably a 1.5 year effort just to develop some of those templates and a significant number of lessons learned. But we keep going. And then after we got to that point of what we felt it was the right way to go, we started training people. And we trained 12 integrators, and we plan on adding another 2024 in this year. We selected more like an EPC type contractor to help us with a lot of the heavy lifting on the implementation of some of those projects, because they were a lot larger than what the local companies were used to do. And we partnered with Bedrock on local vendor support, and they've been instrumental in helping us setting up that. In addition to that, we started training technicians, and this is really just a snapshot of what we did. At some point, we ended up adding a list that was close to 100 people that we need to train in the company, and everybody from, is this in telecom, instrument techs, automation technicians, electricians that are company, electricians that are contractors. So it was a significant effort that is still being developed. And then we select the preferred platform. So this was probably the 3 most important things that we work on in terms of what drove the decision-making process. What was the things that we said, you know what, if it has those 3 things, then we're going to push it, and we're going to work with whoever we select to make it work. And it was built-in security, right? That was and again, I have to thank Alan, because he fought it through and fight to make sure that we stay on that path. For many years, it was just bolt-on, right? You have to secure the system wasn't intrinsically secure, and you have to go through all kinds of hoops just to make it secure. So one of the drivers is to make sure that that wasn't the case, that it was designed with the cybersecurity in mind, and we didn't have to put a lot of energy to make it secure. The lifecycle cost was another one, and again, this is actually a mixture of cybersecurity requirements, because if the cybersecurity requirements change every so often, that means the company had to invest money to secure that platform every so often. So that becomes an important aspect of the decision-making process. And we wanted to have a platform that was designed to last at least 30, 50 years. And so cost of ownership is, total cost of ownership, it included easy to support, easy to maintain, easy to secure, and with a good local support. And everybody felt that it was a cost-effective solution. So it wasn't like the most expensive or the cheapest solution. So it was a combination of total capital investment, but also looking at how much it would cost in the long term. So this is kind of as part of the process, we found that it's either built-in or bolt-on. So when it's bolt-on, you put all those things to make the system secure, and it takes a lot of energy to maintain. So I know I heard a lot of things about processes, meaning that we have to put processes in place to make sure that they're actively enabled at all times, right? And that takes energy, that takes hours from the organization, and we felt that this is not what we wanted. We wanted a system that had built-in security, so we didn't have to spend that much time doing that. So that led us to built-in. So built-in, this is pretty much a lot of the items from Bedrock platform in terms of characteristics, which is one of the questions. So root of trust in a philosophy of zero trust that we have right now in the company. Root of trust was really the path to make sure that we always know who we're communicating with. And so Bedrock was one of the platforms that had that. And it was significantly more secure than many other ones that we look on that space. So really, they designed the product from cybersecurity in mind, and then that was something that we were very impressed, and they were willing to work with us. We were willing to work with them, and that's how we move forward with them. So after that, we went through the selection process and we said, all right, now this is the platform, this is what we want. Now we start putting pilots in place. We started with one pilot, and then, as you can see geographically, we have 5 fields. Some of those fields are 5 hours apart from each other. So unfortunately, one pilot wasn't enough because we needed to test support models on different locations. And so we ended up with one, then we added another one, and then we landed on 3 in the end. And, and then we developed a lifecycle plan. So how do we manage this long-term? So we ended up developing a 30 to 50-year replacement plan for all the PLCs company-wide. So that was an interesting journey. So it's still being revised and updated, and it's probably going to be evergreen around that. So those are the 2 things that allow us to do once we got into that selection process. So the other thing that we probably didn't talk about too much about was the open source concept, right? I mean, we found there's a number of libraries out there that for free that we can leverage, and so that kind of allow us to really be a little bit less depending on vendors adding functionality. And sometimes vendors only limit themselves to what they can do, and then they always have another product or another software or another system that they can use. So the first version of the library was using OSCAT, which is part of that open source community for automation technology. And this is just an example of some of those templates, and they were fairly easy to adopt. And it wasn't necessarily easy to implement, but I think the information was available, and with enough testing and working with the vendor, we were able to adopt open source for the project. So after that, we said, okay, now we had the libraries, now we had the support model. Now we need to, anything from just even local distributors, there's just mundane things is, what do we buy from? How do we get support? How do we pay for resources from the vendor to support us? So it was really, a lot of that was a lot of contracting work happening in the background, working with procurement, and endless hours trying to figure out how to navigate through anything from terms and conditions and negotiating contracts with multiple people to kind of develop that support model. So that took us a lot more energy than we expected. I think we spent probably a good, I'm going to say 6-7 months just navigating through that. So what are the things we did on the software? We talked about this is all the things that we were able to bring. We developed that library. We developed a user group. So one of the things in the user group is that we did not have a way to communicate improvements with the vendor. They didn't have a structure. They were young enough that they were eager to help us out, but the process on how to communicate best practices and how to integrate functionality, whether or not it was cyber, whether or not it was system or operational improvements, it wasn't clean. So we established a user group, and we started working a lot closer with the vendor. And the vendor, once they realized the amount of things that we wanted to improve, then assemble another team and start helping us accelerating that. And I think they probably updated the firmware, 4 times since we started this effort, I would say, maybe even more. So vendors being instrumental in whatever we throw at them, then they go and try to make sure that they implement it very quickly. We also added training. That was an interesting thing. It's not always very visible. Is that we put all these engineering requirements, cybersecurity requirements, and then the technician that is supporting that, it's just left out, right? And then we did one training, and it was very integrator-centric, and it didn't work. So they couldn't connect enough with the product, and we brought someone else and have another training session, and it was a lot better. And then on the 3rd version of that training, finally got to that point where they felt connected to the training. And then from there, then they start trusting and adopting the platform a lot more. And it's a lot of resistance at the beginning with the platform. So And part of that was really to engage them in the process of whatever issues they were having with the platform, making sure that we were listening to them, putting it on the users group requirements, and then communicating to the vendors. So once we get that feedback, and then we show them that what they were asking for, we were actually acting on it and making sure that those improvements were there to make their life easier. The trust with the team got a lot better, and we saw a significant amount of improvements in communication and adoption rate for that. The other thing that they did for us was very interesting is that they have a terminal assembly that they updated for us. And this is interesting because we put almost cybersecurity as the primary reason for going with that product. There were some things on the product that people like the electricians didn't like, right? And then said, all right, so how can we improve that? And then we did a FMEA on all the components and provided feedback to them. And this is the first time I've seen anything like that in industry. Within 6 weeks, they come back and said, all right, those are the new parts. I said, what do you mean? They said, we designed new parts for you. And they did. And based on feedback provided in an amazing turnaround, they actually created prototypes for us, and we tested the prototypes, and the improvements were significant. So they almost eliminated all engineering from non-effort. So now it's just not cybersecurity. Now engineering time got reduced, and now it became a more consolidated version of what we wanted to see. Is something easy to engineer, easy to deploy, friendly to the end users, and cyber secure at the core. So without going through all those lines, I think it made it very simple, very easy to deploy. I would say it cut probably the engineering in half, and we were able to order 70% of the hardware that we needed for around 12,000 I/O points within probably 3 weeks. So we pre-designed a lot of that with some tools that we work with the vendors. So that was very impressive. I never seen anything like it. So there were some disadvantages because we created those terminals. Now we added a little bit of cost, but I thought it was worth the extra capital if we would create the savings on engineering, and it would help with the adoption. So we put cyber as the number one priority, but we work with our customers, in this case, the automation technicians and the electricians, to make sure that what they were getting, it was also friendly on their end. And so I will go very quickly through some of those. This is some of the cars that they developed. This is a relay car that they developed for us. So the electricians didn't like the analog output, and they wanted to see relays on the cars, and they developed that for us. So that now improve safety because they isolate. So now you have something that is intrinsically secure, it's reliable, easy to design, and now we also improve the safety aspect of it. So now we're looking at the 3 things that are very important on the project side. Develop this other module for us. There was a 120 with fuses, so those are fuses. So technically, you don't have to design fuses anymore on your panels. It's all built into the car, which the deployment speed got significantly increased after that. And they also developed this very innovative, in my opinion, universal analog input, analog output car, DIDO, using automotive fusing. So I'm sure that at some point, 10 years from now, we'll see a bunch of fuses with 20 amps there. So probably went to the gas station and pick a fuse. So I'm sure at some point we'll see some of that, and we're looking forward to that. So that became very flexible. It was an easy design and very clean. So did a great job at that. So anyway, in terms of what is the summary of what we learned on this journey is that we started with cybersecurity in mind, and we ended up decreasing engineering design time and a lot of those projects. We added flexibility. We can easily deploy those solutions. We reduced safety exposure because we redesigned the cars at the electrician level, so they don't have to wire anything. That way they don't have to make mistakes on the wiring side. We reduced the complexity on the software using open source. We lower the total cost of ownership, combination of things, cybersecurity, one of the biggest one in terms of total cost of ownership, and enable higher levels of troubleshooting, standardized solution, and because of the significant amount of diagnostics that we now have an enhanced data quality sets of data that we can use to determine if we have issues or not. The only disadvantage is we have to invest a little bit more capital. I'm not sure if I can share the amount, but it was not enough for us to not to proceed with that solution. When we did the economics, it was better to invest the capital and than having to deal with all the other things on the back end. It's an example of how it looks like. You're curious? This was our first pilot. This was not a very clean system. Cables didn't fit. Electricians did the installation. They made no mistakes. They have upgraded the whole system by themselves. And a lot of the integration was done in-house. And Alan's team did a lot of that programming with the technicians, and it was fairly easy to do. It wasn't complicated at all. So, but we learned, and then on version 2 we got a little bit more cleaner. So learning a little bit more. This is another version of their product. This is a little bit smaller unit. They all use the same terminal assembly, so you can use it on all the platforms. They're interchangeable. They call it an OSA remote, which is just a smaller footprint PLC. So this was a good example of they wanted 3 signals on a compressor, and we were able to put one system that it was smaller to get the 3 signals, and then in the future what we're going to do, we're going to replace that one. We're going to put a bigger one. And because the code is the same and the terminal assemblies are the same, we can pretty much enable things faster in the field. This one was no engineering. Guys just took the panel. They took probably 2 weeks to do from start to finish, from design to installation. It's a good example of a turnaround that I haven't seen in the past in control system. It takes months to take anything off the ground. And this is our last pilot. So. And that's it. So this is another injection header that we're building. And now we're testing different signals. We are testing if 6 to 8 volts, just weird signals to see if the system would take it. That one is going to go on production probably over the next week or so. And that's it.